Hello everyone. Today I'm gonna show you our practical tutorial on how to code basic approaches, as well as how to load the data and to measure metrics of those approaches. Here you can see my cursor environment. Um, I created this notebook not from scratch as I did before on my previous jobs, but rather by using cursor agents. I like to use agents Sonnet 4.6 for basic work, and then also to evaluate everything about if there are some bugs or critical fixes. I like to use higher models, like for this time it's Opus 4.8. Yeah. In this notebook, we're gonna talk about data loading, about how we split our data. If you don't know what I'm talking about right now, you should uh, visit the first lecture, and there I explain why we use different splits, why we use different metric functions, and so on. So, as I told you earlier, this practice is mainly for those familiar with Python. Nothing else is that important, but you should also be able to set up everything for your workflow. And I'm mainly using WSL setup for Windows, as I'm currently on Windows. This is like an Ubuntu distributory for your Windows machine where you can install all the libraries, your Python, for example, check my Python version. This is 3.14 and so on. Yeah, but for this particular um, project, we will be using mainly Python 3.12. So let me check that for you. Yeah. This is something you can ask your agents to install for you. Now you don't need to do that from scratch. And if something goes wrong, you can always ask your agent. And this is how life is much easier now. So let's start. For our tutorial, we will be mainly using dataset Yamda, which I talked about earlier. And this is a dataset of music recommendations for music recommendations. It's open dataset from Yandex. It contains different events, like for example, listens, likes, dislikes, and some other events. We will be mainly using listen and like events as they are most informative ones. To load the data, we will be using pandas as well as Hugging Face datasets library because the dataset um, is placed on that uh, on that uh, on that website. And we will be also using NumPy to compute our metrics and for other things as well. So let's start our notebook. Yeah, I have loaded the dataset previously. That's why it should be cached and it will run faster than in your environment. Um, I'm also using a smaller version of the dataset with 50 million events at most. And this is how it looks like. It's about 47 million events, from which we have about 800,000 like events. We have about 800,000 unique items, which are tracks in our case, and about 10K users. We also have about 46 and a half million listen events. After loading, this is how it loads. So all the data set is in the train key. We convert it to pandas. We filter everything to only preserve listens and likes. And we also create different columns in pandas for our is listen and is like for easier future use. But again, I want to notice that I didn't code everything this from scratch, and I used mainly cursor agent with some kind of a big prompt where I passed all the context I needed. Something like, please, let's um, yeah, it's here. Please, let's create the plan for this project where I want to use popular songs, new songs, where I want to measure different metrics with eval functions and so on. So I wasn't coding that myself. The cursor was coding it, but I reviewed and everything is good. And that's how I would do it myself. So that's why I explained it to you. Yeah. And so we only filter user ID, item ID, which is track ID, timestamp. This is the time when the event happened. Is like, which is our column if the track was liked. Is listen, which is our column if the track was listened. Yeah, this is the sample of data, as you can see. For example, user 100 listened some tracks in different timestamps. He didn't like them. He only listened to them. Yeah. Here we can see what is our timestamps. Like minimum is 0 and maximum is 26 million. This is not that interpretive, but we don't need that. This was used for anonymization of data so that you couldn't find out what is the user number 100. Yeah, and we have about 7.5 thousands of users who have both likes and listens. As I talked earlier, for every train algorithm, you need to split your data into train and test. So you can train your model on the train data and then test it on the evaluation data. And usually this is done in 80% train data, 20% validation data direction. So in order to do that, we need to find such a timestamp. As we are doing temporal split, we need to find timestamp that divides our data into 80 to 20% parts. So this is how we find it. And then we divide the data. And we have train with 38 million events and validation. For metrics, we will be mainly using precision recall, hit rate, and also coverage for now. We discussed precision recall and hit rate in the previous lecture. What about coverage? This is a metric uh, which covers all of your data and shows how much of a percentage you have of whole your catalog covered. So if your system is conservative and it only recommends certain tracks, it will have low coverage. And in the opposite, if your system is very random and it tries to always randomly recommend something to the user, it will have huge coverage. Yeah, here we have those metrics. This is just them coded by their definitions. So each metric is computed for each score. And then we have it averaged, which is numpy.min. This is average of scores. And so for each user, we have recommendations. And we also have ground truth, which is actually what the user listened or liked. And then we take top K items from our recommendations. And if we have something relevant from those recommended items, uh, then we count them as one. And if we don't have something, they are zeros. And then we have all of them divided by k. This is the formula. Almost same for recall. but this time we are using not division by k, but division by total number of relevant. And also hit rate is if we have at least one relevant item. And for coverage, we need the whole catalog passed in, so we know the number of total tracks. And then we also need all the recommendations to all the users. And so we find all the unique recommendation tracks and all the unique catalog, and we just divide recommended by the catalog. Yeah, I forgot to actually execute the cells. Let's execute them. We'll find our threshold. It will define all the functions. Then we also have evaluate function, which takes our train dataset, validation dataset, our model, which is something like we train our target. So we can evaluate rather by likes or by listens. This is what I talked about earlier. You can evaluate by both of them. You can evaluate by some other target. For example, in your data, this is order. You can evaluate by order, precision by order, recall by order, coverage by order, and so on. And also K, which is how many first items do we consider for evaluation of the metric. Yeah, here we actually have our true data grouped by user so that we have all the relevant tracks. We have our catalog for coverage computation. We have all the users we need to evaluate on, and recommendations, which is empty uh, unless we have a model predict for each of the users. And here is also TQDM used. This is a wrapper function for your for loop, and it displays how many users you have and how much time do you need to wait more. Yeah, so this is only definition. Let's define that too. And now we will discuss basic approaches. So as it was previously, we discussed that some of the basic approaches are popular songs recommendations, also new items recommendations, and also something that you have already interacted with. Like, for example, if you are trying to buy e-groceries and you always like to buy milk, then if we recommend you milk, you will buy it again. Or, for example, if you like to listen to music and you like to listen to, I don't know, maybe Kanye West or some other artist, and we will recommend that to you, you will listen to it more and you will like our recommendations actually. And so, what's the point of popular songs recommender? Is that we sample all the most popular songs and then we recommend to all of the users the same set of songs, which is actually all the sorted songs, and we just um, get K of them and recommend them. So in train, it just creates this distribution and sorts everything on how many times did the song appear. And then in prediction, it takes K first. Yeah. So in our case, that would be top 10 most popular items, some tracks. And we can measure all the metrics for both listens and likes. And as we have already defined, we have evaluate function. So we can actually just run this cell. Yeah, I also forgot I have a bug here. And that's because my evaluate function in predict, we have user and K. And here I have no user. Yeah, so I need to do that. And I also need to do that. Yeah, this is how it should run. Yeah, so here are the metrics. I'm gonna say this is pretty good metrics. Those are pretty good metrics for such a basic approach. So we have precision about 0.22. And of course, likes will always have um, less value in metrics than listens because likes are much stronger signal. And in order to say that you like a song, it's much stronger signal than just listen to it. Or for example, if we had orders, for example, so if, for example, it was for Amazon and we had views or likes, for example, add to favorites or order, so order would be the strongest signal in our data set. But those are pretty good metrics, as you will see. Of course, we have almost zero coverage. That's because we are recommending popular songs, the same songs to all the users, and we don't cover our catalog at all. We only selected some tracks and recommend them. The second approach, and I also see that I have a bug here in predict function. I need to also add the thing here. Yeah, I was removing it previously manually, and then I forgot that it wouldn't work if I remove that because we have general structure of the same class for evaluate function. Yeah, in new tracks we have uh, tracks which are the closest to the test production date. So in our case, this is a T star timestamp from which we divided our data into train and validation. So in our case, this is some sort of beginning of validation, and we need to find the newest songs for that particular moment. And we find them by taking the minimum of timestamp. And we also try to find such items that weren't encountered in users' listening. Yeah, those are again some item IDs, which are the newest tracks. And we can again evaluate them on the metrics. But as you can see, those are the metrics. They are much smaller than before. And that's because recommending something new isn't always the best case scenario. You shouldn't be recommending something new without any other model or any other approach. Usually recommending something new is a good solution for breaking out of the feedback loop. And feedback loop is something that happens when your model tries to recommend you the same things you have already bought or you have already listened to. So this is a typical recommendation systems problem. And when you try to recommend something new, and then you will have uh, sort of break through that um, feedback loop. But you shouldn't be using this method as a standalone method. It wouldn't work, as you can see. And we also have the third approach, which is already consumed. So we recommend items that user has already listened to or liked in the training period. And so we use the best values based on the listen count. So we group all the items based on their listen count, and then we take first K of them to predict. For example, if your favorite song is Kanye West Power, we will recommend it on and see how well it behaves. So we define the class, we train the model. One thing I want to discuss, all the previous models were using static recommendations, sort of. So they were the same for every user, but this approach is dynamic in a user's way. So each user has its own recommended items. For example, if we recommend something for user 100, we have these tracks. But if we, for example, take, I don't know, which users do we actually have? Let's find out. For example, like this, and let's make it to list, like this, and take the first 5. I'm doing that to find out what are actually the, yeah, let's use this one, like this. Yeah, for example, we don't have ID 101, we have 200. That's what I needed to know. And we can see that for the other user, we would have another IDs. Yeah, this is what it was for user 100. So they are different. And if we take it in the popular songs, their predict doesn't take user ID into account. Yeah. Okay. So we can again compute all the metrics, listens and likes. And as you can see, those are the metrics. Here is the whole summary of all the approaches. This is sorted by precision. And as you can see, by likes, just recommending popular songs is the best approach. And I think that should be um, evident that this approach is better than already consumed or new songs, because if you really like the track, you will already like it. So you don't need to be recommended this track to be liked. But in terms of listens, of course, already consumed beats all the other approaches, and it's the best approach. And what it basically says that in 10 recommended songs, you will listen to at least 5 of them from this approach. And from popular songs, from 10 recommended songs, on average, a user will listen to at least 2 of them. Yeah, and here I would say that in 100 songs, maybe. Well, no, you shouldn't interpret it that way. Okay, so I wouldn't try to interpret that. So this is all for today. I hope this tutorial was practical and useful enough for you. I will make this code public in GitLab, and I will send the link to description once I have an access to do so, because YouTube needs to verify me. And thank you all. Thank you for coming and listening. And the next lesson, we will have some new approaches about collaboration techniques. Yeah, thank you.